Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem 2200. Find all k distant integers in an array. This problem is based on arrays and it's a beginner friendly easy problem asked in companies like Google and Amazon recently. In this problem we'll be utilizing prefix sum concept, keeping it pretty straightforward and simple to optimize it further from order of n square, brute force to optimized one. Let's have a look on the problem statement. You are given 0 indexed integer array nums and 2 integers key and k as shown in the example. Nums array is given to us, 2 integers k and key is also given to us. After that they are saying a k distant index is an index I of nums for which there exists at least one index j such that the difference between I and j is less than equal to k and the value present at j should be equal to key. Okay, so first line is saying that these three items are given to us, and the second line is saying that let's say for any index I, here in this case k is equal to 1, key is equal to 9, so this key is equal to 9, so this key is possible values of j. What we have to find out is we have to find out I such that the difference between these two should be less than equal to k and value present at j should be equal to key. So j only have two possible values, this and this, as per this example. Okay, this is the statement, and what we have to return a list of all k distant indices sorted in increasing order. This is our problem statement. I also have a look at the constraints. Nums dot length will go till 1000, nums value will go till 1000, and key is an integer from the array nums. So we always going to have a valid key, and the value of k can also go till the length of this nums array. Now the problem statement is clear, and I will just explain it again to you. This is our array given to us. If I mark the indices 0, 1, 2, 3, 4, 5, 6, we have to find out or collect all the valid i's, and I will be valid if for any particular value of j such that the difference between these two is less than equal to k and value at j is equal to key. So these two conditions are true, then we have to capture I. So in this case, if I just try to do the dry run with a simple brute force manner, whether 0 can be my answer or not. 0 can be my answer. Let's say first of all let's try to see nearest j. If I try to find the nearest j, I'll be able to get the minimum distance, least distance. Delta should be minimum. So nearest j is 2. So 2 minus 0. 2 minus 0 should be less than equal to k, and value of k is 1. So no, 0 is not a valid k distant index. What about 1? 0 is done. I am at 1. 1. The nearest value of j is 2. 2 minus 1 is 1. 1 is less than equal to 1. It means this first condition is true, right? And second condition is also true because we are picking j accordingly if the value is equal to k. So 1 is a valid one. So 1 I can capture in my answer. What about 2? For 2, I is equal to 2 and j is also 2. The delta is less than equal to k. It's valid. Capture it. 3, yes, these two will form a valid ij pair. For this 4, these two will form a valid ij pair. 5 is already at j. 6, these two will form a valid ij pair. So 1, 2, 3, 4, 5, 6, these are valid. These are valid k distant index, and this list we have to return from this function. So what I did here is, what I need to figure out all the possible values of I. All the possible values of I satisfying these two conditions. I minus j modulus less than equal to k, and the value, not and, let me write for all value at j is equal to k. So whatever value at j is equal to k, those are the items we can place here, and we have to find out all the values of I. So instead what I can do is I can go with the brute force iteration over this array for valid value of I. For I is equal to 0, I less than equal to n minus 1, I plus plus. For every possible value of I, what I need to find out is value j. And this is to check whether this item is a k distant index. And j can be anywhere. Let's say this is my current I. And what should be the value of j? J can be anywhere. Like just iterate over this whole array, find the value of j such that j minus I modulus is less than equal to k. We are good to go. And j I will be picking if the value is equal to key. Checking all possible value of I. Checking all possible value of j less than equal to n minus 1 j plus plus. Checking all possible value of j. I am going to pick j if value of at j is equal to key. And if this is the key and j minus I modulus is less than equal to k, then I is a valid candidate for my answer. Capture I in the list. And if this I is captured, there is no need to go ahead further in this for loop for j, and just break it. So this is my external for loop. Internal for loop, if j is a valid key, then do this and break it. At the end I will be having all the possible values of I. So here what I did is one loop for this and one loop for this. In short, we are going order of n into n, order of n square time in this case. But can we reduce it further? Yes, we can reduce it further, but we can reduce it to n into k. Why? Because let's say in this case I am going for every possible value of j, but instead what I can do is, let's say at particularly I am at this I have fixed I, so this value should be I minus k, and this value should be I plus k. So k item on the left side, k item on the right side, and this particular item. So if I try to search in this range will be 2k plus 1. So outer loop is for I, that is for order of n times, and this is 2k plus 1 time, and the value of k can also go till the length of this n. So in this case it is not going to make any sense. If the value of k is very less, then our approach can be something like this, order of n into k. If the value of k is less, it can go almost linear, but in this case this approach is not going to optimize further. So to my brute force, what I can do here, if somehow let's say I am at this I index, if someone tell me what is the nearest j, valid j on the left side and valid j on the right side, if someone is going to tell me the valid j on the left side, valid j on the right side, I can directly calculate whether the distance, left side distance or right side distance, if any one of the distance is less than equal to k, then I have my answer. So this pre-processing is going to help us here. Let me take the same array again and we'll be working on our optimized approach. Value of k is 1, key is 9. If the value of key is 9, it means that these two are valid j. These two are valid j. And what I will do is I will calculate for all the possible value of I will check what is the nearest j on the left side and what is the nearest j on the right side. Check this distance, check this distance. If any one of the distance is less than or equal to k, I have the answer. And to get what is the left side j and what is the right side j, what we can do? We can utilize prefix sum trick from arrays. Prefix sum style. Prefix sum is going to help us do the pre-processing. Let's do the pre-processing. Let me take an array, and this array is, let's say, going to be left. For every particular value of I, it will give me the nearest valid j from less than or equal to I. For every possible less than or equal to I, it is going to give me the valid j. It means till this, what is the nearest j? There is no nearest j. It is minus infinity. And what is the nearest j on the left side for I? For 4, no, there is no nearest j. And what is the nearest j for this 2? 2 itself is j, so 2 is the answer. What about 3? This 2 is the nearest j. 2. And what about this 4? 2 is the nearest j on the left side. We are only concerned about left section here. We can't capture left and right both in the one case. So for 4, 2 is the nearest. For 5, 5 itself is the valid j. For 6, 5 is the valid j. This array is going to give me what is the valid j on the left side of my current element. And what about the right? What is the valid j on the right side of my current I? Infinity. For 5 is infinity. For 9 it is 5. For 3 it is 9, which is 5. For 1 it is 5. For this 9 it is 2. And for 4 it is 2 and it is 2. So this is something for every possible value of I. What is the nearest j on the left side? Nearest j on the right side. And how do I get the answer? How do I ensure that the valid I is valid or not? If left position, this is bigger than li, so I minus li less than or equal to k, or jr minus I less than or equal to k, I have the answer. But I will check with li if li is valid, and if I is valid, okay, let's check for one case. See, this is 4, 4. 1 minus infinity less than or equal to k. But this value itself is going to give me the garbage value. Infinity plus 1. This is going beyond the integer range. So you have to handle this check explicitly, making here that okay, li is not equal to minus infinity, or taking these two arrays as long. Then you can check. So this is the optimized approach using prefix sum, but here I am utilizing order of n extra space, but I will be able to do it in order of n time. So time is order of n, space is order of n, linear time and linear space. Now I will show you the code. So here in the code, first of all, I have taken an integer list to capture the answer. Then I will be taking two integer array, left array and right array. Left array is going to store the valid nearest valid j on the left side and valid j on the right side, which is nearest in the right side array. And then I have filled this array using prefix sum approach, standard prefix sum approach. And then for every possible value of I, what I am having is I have the valid j on the left side, valid j on the right side of I. So using these two values, I am able to get the answer. So if any of the two condition is true, I'm adding it to the answer. And why I'm not comparing here? If there is no valid on the left side, there is no need to check. Otherwise, let's say for any value of I, I'm subtracting minus infinity from it. There might be some chances of integer overflow and getting a garbage value. Just try avoiding it. So these are the corner cases we need to handle in our code. Then in the end, just capture the answer in the list. And yeah, this was our approach using prefix sum to optimize it to a linear time. Thanks for watching, guys. Bye bye. In case you have any doubt and you have used any other approach, do let me know in the comment section below. Thanks for watching.